in a second. I'll look that up in a second.
Alright, are you ready? Okay, so I'm in your notes. Okay, and I've turned to the page that says washer method dy. Okay, raise your hand. How many of you guys were absent yesterday? One. Only one? Oh, joking? No one was absent? Okay, great. Wow, but you were here.
Wait, you wasn't here?
I was here.
You were?
Okay.
Wow.
Draw a picture.
Oh, you wasn't here? You wasn't here yesterday?
Okay, this is your notes.
Yeah. You wasn't here yesterday.
I missed you.
I missed you.
Are you joking? Were you here or not?
No, he wasn't.
Yes, I was here, but I lost the notes.
No, he wasn't here.
Miss Joyner.
Do you have the notes too? I lost my notes.
You are sure?
Yeah.
Miss Shocking. So,
What?
shocking.
Yeah, Miss Jen. I made that nickname, bro.
Where are you, Brett?
That's not her name.
You know?
Brett.
Oh, is this for you?
Okay.
Yesterday.
Wow. Okay. So what we're gonna do today is the same thing we did yesterday, washer method, but we're gonna do it dy. So if you were here yesterday and you already understand that, cool. Today should be easy. If you weren't here yesterday, which it sounds like maybe some of you were only mentally not here, okay, then you should be fine. Okay, so sketch your graph. I'm just making one up for the top part, and then we'll do equations on 1 and 2. Okay, so here's my made-up graph. There's your region. Okay, and we are going to rotate this region around a vertical axis. Now, I want you to think about yesterday. We were rotating around horizontal lines yesterday. That was dy. Now we're rotating around a vertical line. That's what makes it dy. So the first thing that I want you to do is to draw your capital R. If you were here yesterday, that goes from here to the farther away function. That's capital R. And then your lowercase r is going to go from here to here. And that's your little r of y. Now, what I want to point out to you is that instead of being top minus bottom, these are both going to be what? Right minus left. Okay, so r of y and r of y will be right minus left. And then the other thing is that, remember, if your integral is dy, then you're going to need to know the c and d, which are going to be y equals c and y equals d. So your end points here and here have to both be y values. Okay? So then everything else from there, same as yesterday. Volume equals pi integral c to d. And then I'm going to do r of y squared minus little r of y squared dy. Now, I'm going to put an extra set of parentheses around this just because you're supposed to, okay, but it seems like that looks like too many parentheses, but it's just you're squaring r of y, capital and lower, okay? Also, remember we discussed yesterday, you can do them as separate integrals or you can do them together, it doesn't matter. Last thing I want to point out before we keep going. What equation form do you have to have? Y equals or x equals if you're doing it dy? X equals. So your dy needs x equals equations. Okay, now the other thing I want to point out to you is that if it is a y equals equation, they gave it to you in that form so that you can graph it more easily. Okay, not to trick you, but because most of y'all can graph with y equals. So look at number 1. Okay, it says y equals square root 4x That's going to be here. And then y equals 2x squared, that's going to be here. And I would draw it maybe a little bit big so that you have room to draw your r's and shade and all that kind of stuff. Okay, so here's my region. Okay, then what I need are my intersections, and I need my equations to be an x equals. So I'm going to do the x equals on the equations first before I do anything else. So if my original equation was y equals square root 4x, okay, I'm going to square both sides so that it'd just be a 4x. And then I'm going to divide by 4, yep, it'll be y squared over, y squared over 4. Okay, that's my first equation. Now, keep in mind that that is this one. Okay, so that's that one. Okay, my second equation was y equals 2x squared, so I'm going to have to resolve that one. So if I have y equals 2x squared, I'm going to have y over 2 equals x squared. And then I'm going to square root both sides so that x is going to equal the square root of y over 2. Now, technically, is it plus or minus the square root? Yes, but since we're in quadrant 1, that'd only be this one. Okay, so that is this one. I'm going to label it here. Okay? From here, the other thing that I need besides my equations are my what? Intersections. And to find your intersections, you take these two guys and you set them equal. So I'm going to do that over here on the side. Intersections. I have y squared over 4 equal to root y over 2. Okay, now this one is not really hard to solve, but it gets a little weird. What would you need to do first? Okay, you need to square both sides. This is why. If you have a square root, you can't move terms around and stuff with that there. So I'm going to square here, and I'm going to square here. Now, when I square my fraction side, y squared squared is y to the what? And then 4 squared on the bottom is now a 16. Over here, my square to my square root cross out. It's just a y over 2. So no, because the 2 was in the house as well. It was in the square root as well. Okay, from here, I'm going to times everything by 16 to get rid of the fraction. So now my y to the 4th over 16 is just a normal y to the 4th. And my y over 2, if I times it by 16, is now a what? 8y. Very good. And then the reason that I want it like that is so that I can get everything on the same side and then solve by factoring. So my next move is going to be y to the 4th minus 8y is 0, and then I'm going to factor. So I'm going to take my y out. That leaves me with y cubed minus 8. So what are the two places looking at that factored form that these are going to cross? 0 and the cube root of 8, which is what? 2. Okay, so if you have a cubed in here, you have to remember to cubic root that number that it's with. Okay, so I'm going to come over here to my graph and I'm going to label this is y equals 2. And then this one down here is y equals 0. Okay? Alright, so we have everything that we need. Now we're ready to revolve. So look what it says. We are going to revolve around the y-axis. Now, we talked about yesterday that if you share a side with the region, you're only going to have one r. But if there is a separation between your region and your axis, you're going to have 2 r's. So even though this touches right here, this counts as a 2r or a washer situation. Okay? So draw your capital R. From the axis of revolution to the outside boundary, that would be from here to here. That's your capital R. Yep. So that's my capital R. And then my little r is going to go from that same axis of revolution to the closer function. That's my little r. Now, remember what we said. Your r's are still right minus left. So when I do capital R of y, what am I touching on the right side of my red line? Root y over 2. But then on the other side, what am I touching if this is the y-axis? 0. So you can put a minus 0 if you want to, but since it's the y-axis you're revolving around, you don't really have to put anything there. Okay, little r, here to here. What am I touching on the right? Y squared over 4. What am I touching on the left? So little r of y is y squared over 4 minus 0. And then from there, you're going to do volume equals pi integral big R squared minus little r squared. So root y over 2 squared. I'm not going to put the minus 0, but you could if you wanted to. Okay, and then minus y squared over 4 squared dy. Now, I forgot to write my endpoints. My endpoints, if it's dy, should be the y values of the intersection from where to where? 0 to 2. Good job. Make sense? Okay, now to save us time, okay, look at number 2. We're going to rotate the same region R, but we're going to rotate it just around a different line. So, re-sketch your region. I'm going to only label the important stuff. We already did most of the work, though. Okay, here's my graph. I have this function is x equals y squared over 4. I have this equation, y over 2. And then I already know that this is y equals 2, that this one is y equals 0. So we're re-sketching the same region so that we don't have to do a bunch of extra work. Okay, now what does it say this time that we're going to rotate around? Okay, good. Right here it says we're going to revolve region R around the line x equals -2. That is a vertical line just like the y-axis. So I'm going to do it dy. So there's x equals -2. Hey guys, I don't know what y'all are working on, but can you do it later? Okay. X equals -2, then draw in your r's. Both of your r's should start on that vertical line. So my first r is going to go from here to here. That's my capital R because it's longer. And then my little r is going to go from that line to the closer function, which will be from here to here. Now, it doesn't matter where you draw your r's on the graph. On one side, you should be touching one of the functions, and on the left side, you should be touching x equals -2. Okay, let's do our capital R first. So, yes. So, capital R of y is this line right here. What am I touching on the right side? Square root y over 2. What am I touching on the left side? -2. And so if I do y minus -2, that's really just the y crap plus 2. So I'm going to change it to a plus. Because you're doing the right side is here, and the left side is -2, and it's right minus left. Okay? Now, my little r, what is my right side touching? Y squared over 4. And then on my left side, it's also touching -2. Now, this should make sense to you from a standpoint of if I move my center further away, does it make sense that my radius are just both each 2 longer? Because I scooched it away from my region. Okay? So from there, it would be volume equals pi in the front, 0 to 2. My capital R is root y over 2 plus 2 squared. And then my other one is y squared over 4 plus 2 squared dy. And that would be your volume. Make sense? Okay. Number 3, sketch your graph. Okay, what does y equals x cubed look like? Goes like that, right? Okay, then y equals 0, that's really just the x-axis. And then x equals 2, that would be here. So if I want to stay between the cubic y equals 0 and x equals 2, that's this little kind of triangle shape. Okay? Let's find our relevant intersection points. Okay, so this one is already in x equals, but y equals x cubed, that's not going to work. We're going to have to fix it. So if y is x cubed, what is x? If y equals x cubed, then x equals cubic root y. And that's what I'm going to call this side over here on the left. Now, once I get them both in x equals form, what should I do with them? Set them equal so that I can find my intersections. So this guy and this guy, set them equal. So if the cubic root of y, I'm going to put intersection cubic root y equals 2, then you cube both sides, and y is what? 2 cubed is 8. So up here I have y equals 8, that's my top intersection, and then since I'm having y equals 0 as a side, that's my lower boundary. Okay, what are we revolving around? The y-axis, that's right here. And notice that even though I am touching at that one dot, that doesn't count as adjacent. So I'm going to have 2 r's. Draw your capital R, then draw your little r, and we'll check them in a second. Remember that both of your r's should start on the pink line, but capital R should go past where little r stops. Alexa, you with this, girl? Yes? So capital R is going to go from here all the way to here. That's capital R. And then little r is going to go from here to here. That's little r. Yeah? Did you draw it right? Correctly? Okay, then capital R, right minus left. What am I touching on the right side? What am I touching on the left side? So capital R of y is going to be 2 minus 0. What is little r of y going to be? Cubic root of y minus 0. And then remember, your volume, you slap an integral on it, pi big R squared minus little r squared. Y values were what? 0 to 8. And then you'd have 2 squared minus cubic root y squared dy. Okay.
What's the 8 for? Is it the intersection?
The 8 is the y value of the intersection. Yes, ma'am. Okay, so what we're going to do now is we're going to transition to homework 5. Mark out homework at the top. This is going to be extra credit. Okay, so if you want to do it, cool. You already have a couple of homework assignments. This is not a homework assignment. Homework 5, the one you picked up on the way in today. So at the top of it, I'm going to cross out homework 5 and I'm going to put extra credit. Okay, we're going to set up several of these right now just for practice. The reason that I want to do it is because the regions are already set up, so we have like less crap to have to find. Okay? So when you are rotating around a y equals line, is that horizontal or vertical? Horizontal. Horizontal is like the x-axis. This one is dx. Okay, look at number 2. What are you rotating around? Horizontal or vertical lines? Horizontals like the x-axis, so those are both dx as well. Go down to number 3. What are you rotating around on number 3? X equals and x equals. These are going to be dy. So the way that I would think about it is if you're rotating around the x-axis or another horizontal line, that's going to be dx. But if it's the y-axis or another vertical line, that's going to be dy. So take a look at letter A. It's already done for you, the graph and everything. Okay, graph x equals -1 onto your picture. So -1 would have been back here. Okay, if you want to shade your region, it's kind of already shaded for you, but not very well. It's right here. Okay, I want you to draw your capital R and your little r. Draw your capital R and your little r. Both of your radius lines should be touching the pink line. So capital R is going to go from here to here. And then little r is going to go from here to here. You may. It's fine. Okay, so look at capital R. What is the right side touching over here? Okay, -y², blah, blah, blah. And then what is the left side touching? Not 0, this is 0. -1, yeah. So it would be -y² plus 4y minus -1. And then I'm going to change it to a plus 1. Now, for my little r, that one is touching 0 on one side. What is it touching on the other side? So if I do 0 minus -1, what is my little r? Just +1. Now think about, does it make sense that I got a constant? Okay, if these are both vertical lines, they're always one apart. So it makes sense that we got that because that's how far apart they are the whole time. Okay? So then I'd put volume equals pi integral, where to where? Look at your shaded region. Where does it go from? 1 to 4. And now why am I starting at 1? Where did my shading start? Not till 1. Okay, and then I'm going to keep going. My capital R² is going to be -y² plus 4y plus 1 squared. And then minus 1 squared dy.
Where's the shading supposed to start?
It starts at 1. See this flat line?
Oh.
Yeah, because you're shading between y values. That's a good point. Hello? Hi. Oh, what? Yeah? Yeah? Can I send her down after? Okay, thanks. Okay, cool. Well, Miss Macias wants to see you, but she said you could go after. Okay, okay, now we're just gonna set up B. We're not gonna write the whole thing out. Draw in your new axis. What are we rotating around in part B? Same region, but a different line. X equals 4. So now my region is on the left side and 4 is on the right side. That matters. Okay, so everything in the region though is the same. Draw your capital R and your little r. I just want to see if you draw them correctly. Draw in your capital R and your little r if you're on the left side of your line. It's not going to be 0. It's 0 at this point, but everywhere else it'd be this space. So capital R is going to go from the axis of revolution, what you're revolving around, to the farther away side. That would be to the y-axis. What would right minus left be for that? 4 minus 0, which is 4. Okay, but then for my little r, you have to be careful where you draw it. If you draw it at this one point, it's like, oh, well, there's no radius. Wrong. There is a radius. It's this space here. So at that one point, you're right, you don't have a radius. Okay, but for all of the other points you do, so you have to define it. What is right minus left for the little gray radius? 4 minus -y² plus 4y. Make sense? Okay, so if your line is on the other side, you're just subtracting backwards where your axis would come first. Okay, we're going to do one more, go down to number 4. We're going to only do the x equals 4 one, though. We're going to do this one. So sketch that line into your picture. X equals 4 is going to be on this side. X equals 4 is going to be on that side. And then because I have a vertical axis, what am I going to have to do to my equations? Put them in x equals form. So if it's y equals x squared, that's not going to work. What are we going to have to call it instead? X equals square root y. Okay? So draw in your two r's. Your first r should go from the pink axis of revolution to the farther away side of the region. What are the two things that I'm touching? From 4 till 0. Capital R of y is going to be 4 minus 0. Just set it up. Okay, then your little one will be here. And what will your little r of y be? 4 minus square root y. And then from there, your volume would be pi integral. And then what am I noticing I never found on this one? Oh wait, the intersection's right there. Now, do I go 0 to 4 or 0 to 16? 0 to 16, because those are my y values. So 0 to 16. You're just setting up the volume equation. You don't have to type it in though. Okay, and then from there, it'd be capital R squared, which was just a 4, minus little r squared, which is 4 minus root y squared. Make sense? Okay, I am going to give you a solid 10 minutes to work all the way through free response question number 9 in your packet of death. Okay, so take it out. When I say number 9, I mean this number 9. Okay, because remember the AP test is only 1 through 6. So you have to look at the bottom number. Okay, turn to it. Number 9. You get to use a calculator, yes. If you don't have a calculator, I will happily bring you one. You should be able to set it up though without one. Okay, all the way through. A, B, C. Need one, anybody? You need one, Sean? Okay, need one? Love to share. You guys, you need a calculator? There you go.
Gotta go, please, bud.
We're doing your packet 6, question number 9. Okay, and I will bring you an Oreo if you're doing it. Okay?
We can teach a practice.
Yes, practice.
Hey, what do you
I'll get you. No, I'll get you your own. You have your own? Anybody else need one?
Thank you.
Elizabeth, you need one? We're getting out a calculator, yeah? Okay, you're doing question number 9 out of your packet. Okay? What are you revolving around, the y-axis? You would, because think about it. At this one dot, there's not a hole, so you're right that the hole doesn't go all the way through, but this whole part here will be a hole. And so that counts as washer method because you have, even though your hole doesn't go all the way through the shape, you still have a hollow section that you need to take out. Because it doesn't have to go all the way through. So imagine, trying to think of like a shape without having. Well, okay. I have an example.
Oh my god.
Do you see this lovely pencil sharpener?
I know they're all
If I wanted to find the volume of the pencil sharpener, what would I do? I'd find the volume of this, and then what would I have to do with that hollow part? Minus it out. That's what makes it a washer. Even though the hole doesn't go all the way through, I would have to figure out how big the hole is and then subtract it. That's what washer method does. So if your region is not fully adjacent to what you're rotating around, then you'll have to do washer method. Yes.
No, I never got it. I wasn't here.
Sure. Wait, you told me you were here. All the way through.
I didn't even know that I wasn't here.
It's like I miss you so much all day when you're not
Just
with me.
imagine that I'm there.
That it's like I couldn't even like my mind had to repress that memory. Of you
That
not
was the
being
idea that I was there.
You're doing number 9 off homework 6. Yo, this packet right here. Okay, and you're doing number 9. Right here, this one. All the way through to get an Oreo. All the way. You can do it. You need a calculator, yep. Okay, Kevin, you doing it? Yes? So we're getting homework 6, number 9. That was right there. And you can do all that in your calculator. And y'all remember, find those intersections in the calculator. You don't have to do it by hand. You have a calculator for this AP problem. It says it at the top. Would you like a Oreo? And did you get skipped yesterday? You wanted to too. And then since I didn't get to you wanted to and then since you didn't get okay, so get out a calculator. Do you need a calculator? Okay, so get one out and then start graphing it to find your intersections and stuff. Okay, Marcel, get in here. Come on. No, fail.
That's a the YBD move.
Wabbity moo, get out a
It's
real
an emulator.
calculator. Here.
I have one.
No, I don't trust you.
This? What
Okay,
could I
you were
possibly?
literally snoring. I had to wake you up because like your snoring was like bothering me.
What can I possibly do on my phone?
The possibilities.
When it says no sign change, does that mean it's just 0? When I'm finding the intersection.
Oh, it's because, okay, the reason why is that in your graph you can't see where it crosses, you need to expand your window out.
That makes a difference.
Yeah, if you can't see where they cross, then it can't find it. And then you were asking if this one's right? Yeah. Type it in to see if your answer's right.
But this one, am I doing this one or am I doing
Okay,
a
so
different one?
this is not gonna work. Remember how you have to change it? Would you like a delicious Oreo of joy? Here you go, you're welcome. Okay, you're typing them in, getting your numbers so we can see if they're right. Okay, so have you found your intersections? Okay, good. You can do it in the calculator if you want. Miss Macias is one of the assistant like helpers. So it's probably, she didn't sound like it was bad. She said she had a quick question. So
Is this one like different?
perfect. And then you're typing it into the calculator, not doing it by hand.
Yeah, perfect.
Look at you! That's right. You want one? Okay, for area, should you be like squaring stuff or anything? Just go to Zoom standard. So there's your square root. There's your. And that's really all. Second trace. And then enter. The first one it'll probably give you a 0, 0. So after you find that one, then you'll have to go to the other one. You want one? Okay. You want? Here you go. Tristan, I heard you can't find you. You said out loud, I'm funny. That came with like
More something in the research. That's like that.
but your answer will be the same as mine, so you would get full credit for that. Yes, but you would have to switch the order.
Oh.
That means the only intersection you have is 0, 2. Look at the graph, dude.
One of these.
Notice it's in.
Got one of these.
For this one, for me, and this one.
What one, John?
I'm not working.
Where are you not working? You're in a rough day today.
The next one I was actually was 9.
Yes, and I would write the whole order pair down because later on you're gonna end up needing the y value. So it's 9 comma what? That's last week. Think about it, see if you can do it.
I'm doing it for the process perpendicular to the y-axis.
So then that's where, remember, you draw the basin, and then it says it's a square, so the shape is gonna be A equals B squared. You remember that?
Can you use the graph you need on the previous one?
Uh-huh.
Half a pound of it.
Did that help or no? Right, minus left. Because if it's perpendicular to the y-axis, that means it's running this way, across. Okay, let's check your part A. You should be done with part A because you're not doing it by hand, you're doing it in the calculator. What was this intersection? Okay, x equals 0. What was this intersection? 9. Then when you set up an area integral, it'd be 0 to 9 top minus bottom. What's on top? Square root x minus x over 3 dx. Very good. Now, if you did the integral dy, okay, which I only saw maybe 2 people do, that's not wrong. You're fine. It's the same thing. You should have gotten though what is your answer? 4.5. If you set up your integral dy, your answer still should have come out to be 4.5. Okay, let's go to part B. We're rotating around x equals -1. That's going to be over here. And the first thing that I notice is that my region is not fully adjacent to that line. In fact, this region actually isn't touching it at all. What is going to have to change, though, if I have a vertical axis? How am I going to do my integral? Not dx. It's going to have to be dy. Because which axis is that line like? It's like the y-axis. It's vertical. Okay, so are these endpoints going to work? No. If this is 0, what's the square root of 0?
0.
So this is 0, 0. I'm going to relabel it as a point. And then if this is 9, what is the square root of 9? 9 comma 3. Because I don't only need my x's, I'm going to need my y's. What else has to change if I'm doing it dy? My endpoints and my formulas have to be in what form? X equals. So if this is y equals square root x, what is that? Square, square, x equals y squared. And then if y equals x over 3, what is that going to equal? 3y. So this is x equals 3y. This is x equals y squared. Okay, from here, draw your radius in. Capital R should extend from the axis you're revolving around, so that'd just be your vertical line, all the way to the farther away function right there. So for part B, capital R of y equals, what is the right side? 3y minus -1. And if it's 3y minus -1, that's really 3y plus 1. Okay, little r of y. Perfect. Okay, your little one is going to be from the line to the inside curve. So little r of y is going to be y squared minus negative 1, which is really a plus 1. Okay, if you have not already, I want you to type that in before we go on to part C. So volume equals pi integral 0 to 9, is that right? 0 to 3. And then it's capital R squared, so 3y plus 1 squared minus y squared plus 1 squared dy. So type that in, see what you get. You should get a decimal. In the hundreds. Yep, perfect. Okay, if you get 40 something, you forgot to times by pi.
More so than 4, just 2.
4, always 4.
4.
Yep. Okay, part C, just real quick. Okay, I'm going to redraw my picture. Okay, we have all the relevant facts. What shape do we want? Okay, it says that A is going to be a square, which is B squared. Then I need you to draw your base. It says perpendicular to the y-axis. That means that it runs this way. Is it right minus left or top minus bottom? If it runs sideways, it has to be right minus left. So it would be 3y minus y squared. And then from there, remember, if you turn area into volume, you just integrate it.
What is wrong with 5, dude?
It's extra credit. So 0 to 3, it's not due because it's, I mean, until the end of the quarter, obviously. Like by the AP test, actually, I'm not going to accept anything. So for sure by then. Okay? And then what do you do from there? You type it into your calculator. Okay. Alright, so the goal for tomorrow will be we'll finish up that last little page of notes and then we'll do some more of this packet. Good job. 8.1.
Miss, what do we do after the AP test?
Nothing. So think about it. It's like you're working really hard now to not have to work later. Okay?
That's 4.5.
Maybe. One year we watched all the High School Musicals.